Coming right up, we're going to look at a new power supply. This is a DC step-down module that can take up to 70 volts input and deliver anywhere from 0 to 60 volts at 12 amps output. We're going to try this one out, check out some of the features, put it through its paces, and see what it does. Check it out. So I received this DC power supply to evaluate. Let's just look at the specifications. So this is a 0 to 12 amp, and the input voltage can be between 6 and 70 volts. Output voltage 0 to 60 volts, and it can handle up to 720 watts. This is a DC buck converter, so you have to give it a DC source. You don't plug this thing in. We need to create a DC source to power this from. So let's just open it up and see what's in the box. In other words, I'm going to have to come up with a power supply capable of giving this thing a high enough voltage that we can regulate it. So this is a regulator is what it is. It's a buck converter regulator. And here's the unit. It comes with a, I guess this is a temperature probe, looks like, or some type of, I should read the instructions. Accessories include both a temperature probe, which is used for the battery charging function, as well as a Wi-Fi card for those that want to control it from Wi-Fi through their phone. But that's not necessary. I'm not even going to hook it up to Wi-Fi. I'm just going to do the setup through the front panel controls. So this is designed to build your own power supply. So what we need for this is a source of power. Now, I don't see any instructions in here, so I don't even know everything that they've included in the box. It says I have to go to a website to get the instructions. It says check the instructions before using. I can go and scan the code and go to the website. So the battery holder here is for the clock battery, which does not come with. It's a CR1220 is the battery that is used. I don't have one, so I won't be able to place one in there, and I don't see one in the box. It says you can get one for yourself, so that is that. This is the temperature probe, external temperature probe, and it plugs in right into here. And this little board here, this is actually not a Bluetooth board, it's actually a Wi-Fi board, because this is controllable by Wi-Fi, and it is a special board. They're saying it's a custom board for this, so you can't use a different module, but it just plugs in just like this. Our DC input goes in right here, positive and negative. I'm going to have to come up with something to power this thing up, so let's come up with a source. I've created myself a 48 volt power supply just using 4 12 volt. These are old batteries. These are ones that came out of service because they were testing as being too low for UPS operations, so I grabbed them out of the recycle bin. Actually grabbed about 10 of them, but these are the only 4 that I could actually get to hold a charge. The other one's shot. But we have 48.9 volts DC. And you notice that I am touching these terminals. No, I won't get a shock at 48 volts. If my skin was wet, I'd probably feel this if I put my fingers across both of them. But it's still pretty safe. I've got the plug wired up accordingly. Let's plug this thing in. And it lights up. And there it is, 48.9 watt is my input volts. Now this can be as high as 70 volts. And now we can set our output voltages here. Now I haven't even bothered to to look at the manual for this thing yet, so I'm just trying to figure out what we do here to shift. Have no idea how to work it. See, I should actually go and read the manual. But I believe if I hit V set, I can now dial in the voltage here for voltage set. If I want to shift to the next one over, I just press, what is it here? Press the button. Okay, voltage set. And it's probably this button here. Yeah, that moves me over. So if I want my output to be 12 volts, that's all you need to do. And if I want to set my current to how many amps this thing can draw, if I say take my current limit down to 1 amp, turn that on, we should have about 12 volts on the output. And if we measure the output here, we'll see that we have 12 volts. We should have. Here we go, 12 volts. Let's put a load on here. Let's get a light bulb on here and load this thing up. Now, obviously, a 50 watt halogen bulb is going to draw more than 1.1 amps. So we're going to see this thing go into current limit if I try to do that, because this is probably going to draw closer to 5 amps. So if I go into the current set and I just turn this thing up a bit to say 5 amps, now the light lights up nice and bright. As you can see, it's drawing 4.13 amps. So I could take this back to current set and I could drop it down to 4 amps. And now we're going to limit the light to 4 amps. If I do the same, if I go into current setting and I take it down to 3 amps, as you can see, the light is going to go dimmer because I'm limiting the amount of current. So there's our current limit capability. We can draw up to 12 amps through this, so I'm going to find something that I can put a little bit more power into. This time I've hooked up a HID ballast. This has got a 35 watt HID lamp in it. I've got both the bulbs in parallel. This is probably going to draw close to 8 amps. So I'm cranking up the current to a limit of 12. And we'll turn it on and see that they both strike. And we're drawing almost 9 amps now. So you can see my battery voltage is falling a bit because these batteries are not in terrific shape. But we're still running at 12 volts. Now if we want to turn this power up to say 13.8, go to the voltage setting here. So there's 13.8, what you would see in a car. And it's going to hold it solid at 13.8 volts. Showing we are drawing 110 watts of power right now. This bulb is starting to smoke because it's been touched. Should probably clean that bulb before it blows up. But 104 watts now as the HID comes up to full brightness. I just took the HID bulb and put it inside an old broken, this was a halogen bulb. So I took the bulb burned out, so I just took the little halogen lamp that was inside of it out and stuck the HID and glued it in place just so I have an HID test lamp that'll protect it if the bulb were to shatter. And, oh, that's what's smoking, it's the wires. The wires can't handle the current. So we'll shut that off before I burn up my wires. Anyway, that's how this thing works. And we can take the voltage up considerably higher than this. I think this CAN bus will run on 24 volts as well. Let's see what it says here. It'll take it as high as 32 volts. So we can actually run this other lamp higher in voltage. If I do that with the incandescent bulb, obviously it's going to fry it. But the HID can run anywhere from 9 to 32 volts. So I could take this thing down. If I go to voltage settings here, I could take this thing down to 9 volts. And it should still start, which it does. On 9 volts, it draws 5 amps. And we'll take it up to 32 volts as well. So turn it off, go to voltage settings, 32 volts. And it's only going to draw 1 amp, 1.5 amps at 32. And it's drawing 48 watts, which is what these things will draw to produce 35 watts of light, because you got the losses inside the ballast, right? So people say, I'm going to put some 35 watt HID bulbs in my car because I'm going to save power. It's going to save me fuel. You're still going to draw 45 watts instead of 55. You're saving yourself 10 watts, but much better light, of course, right? We'll take this voltage back down to 12. See, 13 volts. See, it draws the same wattage no matter what, because it's your current times your voltage that delivers your watts. Anyway, this unit here, the voltage will go up as high as 60 volts. Well, it won't go higher than 46.8 now because my input is 47. So it's going to be a couple volts less than your input, but it'll go up as high as 60 volts if you have 70 volts in. So I'm limited to 46. Also has over voltage protection, over current protection, which you can set here on this other setting here. Shift, there we go. Shift and then hit the I set for current setting. And this way you can set an over current protection. So if I set this down at 1 amp, for example, and I set the voltage, and same with this one here, if I hit shift, if I set the voltage down, so for example, if you had something that was sensitive and you could not have more than, say, 14 volts, you could set your limit. So then if it tried to set the voltage any higher, it should let me do it. It should go into over voltage protection, which it does. Goes into over voltage protection, shuts it off, you see. Won't let me turn it on. It'll turn it on as soon as the voltage goes above 14, because I've set it for 16, it'll shut off. Now if I go in here and I go shift voltage setting, and I take that up to the maximum, now it's set for 16 volts. If I turn it on, we got 16 volts. If I take a lead and short it together. Okay, so I got it set for 16 volts. It's got power to it now. If I were to put a short on here, I've got my current limited to, well, we can actually take this lower. Shift over current protection, we'll take this down to, say, 0.5 amp. Okay, now it's on, the current is limited, but I've got the unit set to deliver 12 amps, but I've got the over current protection set to 0.5 amp. So if I take this and short it out, it's going to go into over current protection and shut the voltage off immediately as soon as it hits a 0.5 amp. So you got over current protection, over voltage protection, and voltage and current limiting. That's the difference. Over current protection will prevent the unit from delivering that type of current. It'll shut it down completely. So for example, if I go back into my voltage set, we'll just take this back down to 14 or 13.8 volts, because I'm going to put the light on it again here. We know the light is going to take more than 0.5 amp. It's going to take 4 amps, so it just shuts down immediately and it doesn't come back, right? That's the difference between the overcurrent protection and the current limiting. Overcurrent protection is now set to 6 amps. Our light lights up because it's only going to draw 4 amps. Now I can take the amperage here and I can drop the amperage down. As you can see, now I'm limiting. This is the difference between the overcurrent protection and the current limiting. When I'm limiting the current, the voltage is going to drop because I'm limited to 2.1 amps. Right? The unit is not going to shut down with current limiting. It's just going to limit the amount of current. Whereas with the overcurrent protection, so if I go into shift and go into overcurrent protection, here, once I get down below the 4 amps, it shuts off completely and it doesn't return. So at 4.5, see, I'm drawing right at 4.5 is what the lamp is going to draw when it comes up, and it'll shut down completely as soon as it hits 4.5. If I take this and say, whoops, where am I here? Shift. If I make this 4.6, it should light What are we going to draw? Let's see here. I forget what this thing draws. So let's just let's take it to 5 amps and see what it draws. What it is the bulb draws 4.5 amps, but it draws, when it's cold, it actually draws more. So if I go to shift overcurrent protection, when I get down to 4.4, it should shut off. Right, 4.5 is still working. Hit 4.4, 4.3, it shuts off. We take it back to 5. It won't, because when the filament is cold, it'll draw too much power. Now if I take this limit, I know it draws 4.5, so if I take the limit and say make it to 4.7, it's not going to start, it's going to shut off. But if I turn it on enough to keep the filament hot, it probably will allow me to go. There you go. Because see, when a filament is cold, it draws more current. So to start this thing up, it takes more than 4.7 amps initially, and it shuts down. If I keep it running, it'll run. In fact, I could set this probably to 4.4. And it will continue to run until I shut it off. Right. Once I get the filament warm, it'll keep running once I get it up to temperature. There you go, 4.53, because it draws a little bit more when it's, well, it draws a lot more when it's cold, but as it's warming up, just in that time that it shut off, it cooled down enough that it was drawing more current to get it going. But that's the usefulness of the overcurrent protection. And of course, the overvoltage protection, that's so if you don't want this thing putting out any more power by accident, you can hit shift and go into your voltage set and then take your voltage down to, say, 13.8. Say you don't ever want to go more than 13.8. Now I've got this thing set for 13.86. It won't let it go. As soon as it sees it, it'll shut down. Of course, I've still got my current set here, so that if I take the current, if I take my overcurrent protection up to 12 amps, it'll still shut down because I've got the voltage set to 13.86. So that's a safety. If you set it to 13.8, it won't shut down. But if I set the current or the voltage to 13.81, because I'm just clumsy, it'll shut down. So that will protect your devices that you're testing. So this little module here, this Riden RD6012, would make a great bench power supply for those that want to do it themselves, build their own bench power supply. You know, I've seen so far what I've seen, I like it. So what I'm going to do on this as a future project, I'm going to dig up a transformer that will put out at least 12 amps and one that will put out about 60 odd volts. I'll probably dig one up from an old stereo system. Look for an old receiver that I'm going to gut, pull the big transformer out of it so that I can get a 70 volt power supply and use that to feed this. And I'll have myself a nice little bench power supply which I can limit the current and limit the voltage. So you'll see this unit come up again in another video when I get around to actually putting it to use. But I like what I see so far. It's got nice big heavy inductors in the back here. It's got a fan to cool down the voltage regulation and a good relay here to shut off the power. Capacitors look to be, what are they here? What brand are they? Can we see? They're 330 microfarad. What are they? How many volts are these things? Look like they're 80 volt. Don't see any branding on them. At least from here I don't. Anyway, that's the basic operation of this unit. Power turns it off. And the power light will sit there and blink to indicate that there's power applied to the input. That turns the system on. Okay, there's menus on this unit as well. If I press the shift button and hit menu, that brings me into the menu. This is where you can set up the USB interface or Wi-Fi interface, if I can figure out how to get to this. So we've got multiple memories that can be set for different voltages. Okay, here's how we set the memories, if I can figure this out. I have not read the manual. Okay, I have not read the manual. So we'll figure this out. If I want to set a voltage, say I want to set voltage to 12 volts. And I want to limit the current to 5 amps. And I want to save that to memory, let's say save it to memory 2. So I hit memory, and I hit 2, it says save current settings. And I press in, and I've just saved to memory number 2. Okay, I think I got this thing figured out now. If I want to set, say, 7 volts, 7.5 volts, I'll set it into memory 7, for example. So I'll set my voltage setting to 7.5 volts. And I'll set my current limiting to, say, 1 amp. And I want to save this to memory number 7. I hit memory, I hit 7. It says store current settings. Yes. So now I've set memory number 7 to 7.5 volts. I already had memory 2, I think, set to 12 volts. And memory 1 is set to 5. So I've hit shift and I hit 1. It's telling me that memory 1 is set to 5 volts, 12 amps. Do I want to switch to that? Yes. I've now set my output to 5 volts, 12.1 amps. If I want to read memory number 2, which is the one I just set for 12 volts, 5 amps, memory or shift 2, 12 volts at 5 amps, enter. I've done it. Memory number 7, I set it to 7.5 volts, shift 7, 7.5, 1 amp, enter. I've now set it. So that's a quick way. You've got 9 memories. If you want to set, say, memory 9 to 13.8 volts, wide open, voltage set. 13.8 volts, current set, 12 amps. Memory 9, enter. Okay, now go back to number 7. Okay, 7.5 volts. Go back to memory 9, just go shift 9, enter. We're now at 13.8, 12.1 amps. That's how you control this thing from the keypad. It is fully interfaceable with a computer and through an app on your phone, so you can map out voltages and map out what things drew, like amount of current that devices would draw. That's all covered in the actual manual, which is printed online, which I haven't even gotten into yet. I kind of downloaded it here, and I kind of just briefly glanced at it. But very powerful little unit. You can log all of your settings. It also has a, I think it's got a battery charger in it as well, so you can charge batteries. So you can hook it up to negative and the terminal to charge a battery, and you can use this thing for charging up batteries. Charge a battery. I got a lithium cell here. Connect it up. Battery charge indicator comes up, and it's going to charge it at 4.35 volts. So I guess to charge a battery, you're going to set your voltage. It's 4.2 volts. So we're going to set the power output voltage down. We're going to set this down to 4.2. And we'll set the current down to a safe current to charge the battery. So here's something I just wanted to try something out here. This cell, by the way, is a shot cell. It will not charge. This cell is FUBAR. And this charger can figure that out. I've got it set for 4.3 volts. I've got the maximum current set for 1.5 amps, which is kind of high, but I want to charge my cell up quickly, right? So you notice it shuts off. That's because it's sensing that this cell has a problem. If I get another cell which doesn't have a problem, and we connect this other cell up, these came out of an old cable phone adapter. So a bunch of them, but one of the cells was bad. So this one there, this cell is good. Okay, it'll give me my voltage here. It should show me it here momentarily. measuring at 4.16 now. I've got it set for 4.3. We turn it on, and here's the power that's going in, 1.41 watts. Now obviously we're going to put the little temperature sensor on there so that it can monitor the battery temperature. That way if the battery temperature starts to rise too quickly, it's going to shut off before the battery bursts. But it has detection circuitry in that will determine if the battery is any good or not. If I put this dead cell in my other charger, it's going to do nothing. It'll just show as not usable because this cell is shot. So you can charge up your lithium ion and probably many other types of cells with this as well. I would imagine you could probably charge up gel cells and everything else with full current limiting on this unit. Anyway, I think we've seen the basic features of this. Link to this unit's in the description, and if you want to read about all of the features that it can do, head to the webpage or scan that QR code. That's the owner's manual, instruction manual. If you go to the webpage or go to this link, you can read all about it, all the features it has, what it can do. I've just shown you guys some of the basic features: voltage limiting, current limiting, over voltage and over current protection, and the battery charge features. Now I'm going to put this thing away for now, and we'll see it again when I find a suitable transformer that can give me 60 plus volts so that I can actually utilize this thing to its full potential. Right now, just looking around some of my transformers I've got, they're not heavy enough, but I'm sure if I scrap an old receiver, and I've got a couple of them kicking around here, I can grab a big transformer out of it, grab some big caps out of the receiver, and make myself a half decent power supply. And that'll be a future project. Anyway, for now, thanks for watching.